this one. We'll get to it. You will have extra credit today. So let's see. How far did we get last time? Did we get the scale factor? I think we did. Or maybe we just wrote out, I think we just wrote out the equation. So, oh, and by the way, give Anthony and Dustin a round of applause for that last slide. They did a great job. Excellent job. Thank you for volunteering. I love that. Okay, so it says, just to review, the height of one solid limestone square is 24 meters. Okay, so it was right here. The height here was 24 meters. The height here was 30. And that gave us the volume of the larger pyramid was 16,000 meters cubed. And the volume here, we didn't know, question mark. Okay, and we just, it didn't have it labeled like which one are we going to call figure 1 and figure 2. So we just labeled this first one number 1, I think, right? And then the larger one we called number 2. Oh, well actually I don't know if we did, I don't know. But what we could do, okay, let's read question A. Smaller over larger, okay. And it doesn't really matter, except when you read part A, then it does, okay? So like if they don't specify it, it's not a huge deal. I mean, it could go larger over smaller or smaller over larger, but in part A it says the scale factor of the smaller to the larger. And so that tells you in part A that we do want smaller over larger, okay? So maybe what we should do is call, just because on that previous example from the 3.11 quiz, if we want to keep things consistent, let's call, I don't want to confuse you guys too much, but let's call the first, the smaller pyramid, let's call that volume 2 and height 2, just because when we set up our ratio, since we're dealing with volumes, we'd have t cubed, we'd have volume 2 over volume 1. If we call our smaller, it's smaller to larger, which is volume 2 is our smaller volume over volume 1. Does that confuse you guys too much? Do you guys see what I'm doing here? And you know, I wouldn't stress out too much about the 1 and the 2 for this particular problem. You definitely need to, as long as this part makes sense, you guys should be all right. So the way question part A reads is that we want the scale factor of the smaller to the larger. So that tells you smaller needs to go in the numerator and larger needs to go in the denominator. That's the key, okay? So here's where it gets a little bit tricky. We definitely know volume 1. So if we just have t cubed equals v2 over v1, a lot of students will write this, which is correct. They'll plug in volume 1, or the larger volume, down in the denominator. And that's, so far so good. Except now, if you try to solve that, what's going to happen? Can you do it? How many things do you not know? How many variables are there that you're like, well, I don't know what they are? Ah, Dustin knows what we want to do. Yeah, because right now how we have it written is we have t, which we don't know, and we have the other volume that we don't know. And we can't solve that, right? At least not till you get to Algebra 2. Okay. But we couldn't do it even with Algebra 2 skills here because you have to have another equation. So we wouldn't be able to do it. But yes, Dustin remembers, I remember what t stands for. T is the ratio of the one-dimensional amounts. In this case, it's height. So t is height 2 over height 1. So right here, just for this t, that's what I'm going to put in. Height 2 over height 1, that's my substitution for t. Remember, t is still cubed. So that whole thing, height 2 over height 1, is where the is just for t, and then you still have to cube all that. Okay? Now right now you're probably like, well, how did that help me? Because now I have 3 unknowns, but we actually know height 1 and height 2. Okay, so once I plug those in, I'm going to have 24 over 30 cubed equals volume 2 over 16,000. Okay, so let's take a break there and take a second for that to sink in. Take a look at this. I think from here to here is the hardest part. So remember t, okay, t is equal to height, like a height over a height or a side over a side, because look at the units on height. It's just meters, right? That tells you that that's a one-dimensional measurement. It's just a length. It's not length and width, 2 dimensions, or it's not length, width, and height, 3 dimensions. It's just a length, okay, just the measure of height. So that's what t represents. Yep, t is always a ratio of 1d over 1d. That's right. Okay, so if you're struggling from here to here, it's probably algebra that's getting you. Okay, that's usually what comes back to haunt you in geometry. The geometry part a lot of times will make sense, and then you put algebra with it, and you're like, whoa, what just happened? I got lost. So just for this t right here, we made a substitution. We put this one-dimensional fraction in. Okay, so height 2 over height 1 is for the t. You still have to cube it. Okay? All right, so Dustin's working on it. He says, I think I know the answer. All right, let's see what we get. So remember, I'm going to create a new page so we can just have some room for our algebra. Let's see if Dustin's right. Do you want to write it out for us, Dustin? Do you want to write out what you did? I'll write out this part. If you don't want to, that's okay. But if you want to, all right, go for it. Go for it. Yeah, good question. So can you guys tell me how Dustin got this 13,824? That is correct. Yeah, and again, it's challenging your computation / algebra skills. You have to remember, okay, what are the rules that are allowed? If I have cubed and I have a fraction in there, what can I do? Yes, the cubed applies to both the 24 and the 30. So it's 24 cubed over 30 cubed. So if you type in 24 cubed, you get this number here, and 30 cubed gives you 27,000, okay? Good. Now these are some big numbers, but after this point, you guys have been practicing this quite a bit, so at least you can take a sigh of relief. You know what to do from there, right? I hope anyway, but you want to just cross multiply from this point. Gets a little bit easier after you cube the left. So you got to be real careful because you've done a big, huge number over here. So just be really careful not to, forget a number or something, because that will throw your answer off. But this is a part 2 test, right? What should you guys always do on a part 2 test? Are you going to write the answer for volume 2? Thank you. Type that in caps. Please show all your work, okay? Because if you happen to leave the 8 out right here, I will look at your work and I will say, oh, darn it, they got the final answer wrong, but all they missed was that 8. They just forgot to transfer that onto paper, and that threw their answer off. And so guess what? For something as small as that, I'd probably give you all the points, and I would just let you know, hey, by the way, you dropped the 8, but you had the right idea, okay? Here, like maybe let's say you cubed the 24, but you didn't cube the 30. I'd take off a point for that, but I'd say, hey, by the way, you know, rule when you apply exponents is that you apply it to the numerator and the denominator, but otherwise, great job. Okay, so that, if you just give me 8,191, guess what? You miss all the points. Okay, so please show your work, because I try to, you know, if you just mess up on something, I'll see where that happens and take off appropriate points, okay? So it's better than getting off, because most of these questions are worth usually at least 10 points is kind of the average for a Part 2 test, okay? All right, now that's just Part A, okay? So we got to still do B, C, and D. That's why we started early. So Monday we'll start reviewing for the rest of the test, but at least we'll get some of the Part 2 out of the way. I think the rest of it maybe goes a little easier though once you find that scale factor. All right, so Part B, the ratio of the area of the base of the smaller pyramid to the larger pyramid. Okay, now I cannot tell you how many times I will have students going back on Part B and going back to t squared equals area 2 over area 1. And I totally see where you're going with that. That's a good thought, but it doesn't have to be that complicated, okay? And I think this word right here is where you guys get confused. What does ratio mean? Let's go back to that word. That might help you guys. And also I'm going to write down what we got here. Yeah, proportion. What else could you say? I'm looking for a word that starts with F. There you go. Amelia got fraction. Okay, so ratio is another word for fraction. Okay, so keep in mind that's what this is looking for. It's looking for a fraction. Okay, and it tells you here what the fraction should be. Well, it's the area of the base of the smaller pyramid to the larger pyramid. So we want the area of the smaller over the area of the larger, and that's going to be our ratio. That's going to be our answer. Okay. One thing that's going to help us, let's get, let's see, volume 2, 8192, just from Part A. Think of what we've learned so far. You definitely could, okay, so like I said, the ratio we've learned so far with your scale factor, that is true still. It's still going to apply here. But do you know the areas? I think this is where it gets tricky, because you're trying to think of that or that proportion, which is true, but you kind of get bogged down in the details. I think that's where Part B is tricky. So yeah, Anthony, you're right. We do not know the areas. So typically what students will do is they'll say, okay, well, I don't know those, so I better find them. And you can try to, except there's not quite enough information given in this problem if you try to find the areas, because we don't know like the dimensions of the base there. And so we can't quite figure out what is area 2, what is area 1. But the good news is for Part B, because it seems like that's what you'd need to know. However, you don't know, because all we have to know is the ratio. We don't have to know individually what is A2, what individually is A1. We just have to know what that fraction would be equal to. So think to T. What do I know about T? Look up here at the top, the part I have in red. We know height 2 over height 1, right? Because we just used it for Part A. So can you use that to tell me what the ratio of the areas is? I want you to think about this. Rather than finding the individual areas, how could we find just the ratio, what is area 2 over area 1? I don't need to know area 2 specifically. I don't need to know area 1 specifically. I just have to know if I made a fraction out of this, what would that fraction be equal to? Okay, and my hint to you is that it lies in t. How can we use t to get there? Okay, I think you're on the right track there, Nate. What do you mean by that? Solve it. What do we have to do with the 24 over 30? Okay, simplify, yes. I think you're on the right track. Not totally sure. You guys have to be a little more specific. Or go ahead and write it on the whiteboard. What would you, it might be easier just to write it. If you want to, go for it. What do you guys mean by, so that's right, Anthony, 24 over 30, if you divided it would be 0.8. But what are you going to do with that? What are you going to do with the 24 over 30? That's not quite the answer. There you go, not times 2. That's probably not what you meant, Anthony. I think you have it. There you go, square it. Yes, absolutely. Absolutely, that is what you're going to do. It's the little caret thing above the 6. That's what you guys are trying to find. Okay, so yeah, you're going to, because we know t, we're going to do, it's like for part A. You're going to put 24 over 30 in for t, but then you have to take t and square it, because t up here is squared. And once you complete that, and once you simplify, what is 24 over 30 squared? That's going to be your ratio. And so you don't have to find out what is area 2 individually, what is area 1 individually. All we have to know is what that fraction would be equal to. Does that make sense? Because it's kind of abstract a little bit, so it's sort of, if you're kind of lost, that's okay. Just ask questions. That will help me maybe explain it to you guys a little better, help you over that hump. True, Amelia, true. Okay, so I think, yes, that's right, Anthony. So you could do 0.8 times 0.8. That's fine. That's the same idea as squaring it. Yep. Now, preferably, let's see, what you could do. You could do that, and then you could convert it back to a fraction, although that would be, well, you could do it. It'd only be 64 over 100. Also, you could do, remember, just like we did before when we cubed it, you could do 24 squared over 30 squared. And that would keep it more in fraction form. It'd be a little bit more true to the answer of ratio. Okay. Okay, so now let's try part C. Hopefully this will make part C a little easier. We want the ratio of the volume. Okay, so can somebody help me out there? Want to give it a try? What would we start with? What would be our starting proportion? If we're talking about volumes, what would we have? What's the ratio of the volumes if we already have some information about the scale factor? Now that's good thinking, Nancy. So I like this one. Neat that, okay, I'm going to use my scale factor, 24 over 30, which is perfect. You can certainly do that. And Anthony also said, well, let's see, I actually do know the volumes now, so I could actually just make the ratio with the 8,192 and the 16,000, which is great too. And both of those answers should come out to the same. If you think of scale factor first, and that comes to your mind first, what do you have to do to that scale factor, 24 over 30? What do you have to do to the scale factor of 24 over 30? Since it's a volume, the ratio of the volumes, what power do you have to raise this to? Yeah, you have to cube it. Yep, exactly. But you're going to come out to that 8192 over 1600. Okay, and then you'll probably remember, oh yeah, I already had this over here. I could have just used that. Dang it, why'd I do extra work? But that's okay. At least your thinking is on the right track. That is all that matters. It's only one extra step. It's not a big deal. Okay, so that will be part C once you get that answer. Okay, then oh, okay, so let's see. I guess we should talk about, so if we look at part D, it wants the volume of the smaller pyramid, which is actually what we found. I guess we mistakenly, that's where we stopped for part A. So part A, let's be careful. We actually don't want to say 8192 is our answer for part A. That's actually for part D. Part D wants the volume of the smaller pyramid. So this 8,192 is the volume of the smaller pyramid. We want, for part A, the scale factor. Okay, in simplest form, I think that's the key. And we could have been using that this whole time as well. What would we do? We know the scale factor, right? Tell me the scale factor. Okay, 0.64 or, well, let's see. Is it? No, it's not 0.64. Yeah, there you go, 0.8. What this wants, what I'd prefer you guys do instead of changing it to decimals, give it to me as a fraction. So you're thinking 24 over 30, right? That's where you're starting, which is good. But let's reduce that. How would we reduce? Let's review that as far as fractions go. You just look and see what a common factor is, right? Sorry about that. What's a common factor between 24 and 30? Okay, 6 would go into each. So 24 divided by 6 is 4. And what about 30 divided by 6? 5. So 4/5 is actually the scale factor in simplest form. Okay, so that's part A. And then part D is the actual volume. Okay? All right. Let's go to some extra credit. Okay,